Hey everyone, welcome back to another Breakpoint Show. We just got done in the United States with Memorial Day, so I want to say a big thank you to and remember all those people that fought and actually gave their lives for our country and all the countries around the world. Even though most of the other countries don't celebrate the holiday, but we can still celebrate those people that gave the ultimate sacrifice. It is May 28th. It's a Tuesday. As you can see, we have 4 people in the octagon, I say, and we're going to have a good discussion. We have Daniel. Daniel, you know what? I forgot to even remember your Marbach.
That's okay. Yeah, it's a Swiss German name. It's a complicated name, so it's Marbach, but nobody can pronounce
Marbach. Well, I should have remembered like B-A-C-H is Bach. Bach. So I should have said Marbach. So thank you. I apologize.
Yeah,
that's a pet peeve of mine is to mangle people's names. And Daniel does a lot of speaking and a lot of work with performance. So fast code, efficient code. Sometimes efficient code doesn't mean fast code. It just means that it's the best code that can get your work done. And we will go through all the different nooks and crannies of kind of squeezing out all that performance from your software and application. So welcome, Daniel. You want to do a little 30-second pitch about who you are?
Oh, okay. Yeah, sure. Well, my name is Daniel Marbach. I'm from central Switzerland. So I work for a company called Particular Software. We're the makers of Service Bus and the Particular platform. I've been mostly spending my time in the last 8 years, I think, around sort of messaging middleware and platform tooling around sort of messaging like Azure Service Bus, Amazon SQS storage queues, MSMQ on the old Windows rusty machines and stuff like that. So it has been fun. And as part of that, I usually also do like investigations into, of course, the stack of our customers, basically the stack of our library and framework, but also sometimes it involves digging into third-party code and finding out what's going on. And if I can, I sort of have the mindset, if something is open source, I want to make the world out there a little bit better, and I try to contribute back some improvements, whether it's features or performance improvements. I wouldn't solely call myself a performance engineer. I guess I'm much more than that, but it's definitely near and dear to my heart that code is as efficient as I'd say needed. Yeah.
Awesome. So I always call people like you software archaeologists, because you're always digging in and seeing kind of those where people made the mistakes in the past. So that's awesome.
But it's me, right?
That's you. So you know what? I'll let Khalid kick off the questions this morning. So.
Yeah, I mean, you mentioned helping customers and clients with kind of performance issues. Is it often that you find that it's these kind of issues are complex and have a lot of variety in terms of what causes the performance problems? Or are there like a common set of issues that you see out there in the wild in client code bases?
That's a good question. So
I'll start with a heavy hitter.
Okay. You could come back to that, but the real question I want to ask was, what's better, Swiss chocolate or Belgian chocolate?
Oh, that's a difficult one. I must say that as a Swiss, of course, I have to say Swiss chocolate, but having been in Belgium many times and also tasted the Belgian chocolate, I'm kind of torn. And so off the record, I think both are equally good.
Oh,
good. That's good.
This is not regarded at all.
Diplomatic.
So to be honest.
Yeah.
All right, but back to the original question. I mean, do you find that there's a common set of issues that folks are running into, and or is it typically like a culmination of a bunch of dependencies that create these obscure performance problems.
Okay, so I think there is a famous quote essentially of David Fowler on the internet where he basically said something along the lines of still as of today, one of the biggest performance problems are actually memory allocations, and especially things like byte array allocations and memory stream to array, because that happens a lot. And I just watched Scott Hanselman and Stephen Tobe actually release a new video. It's called The Highly Technical Talk. What a bad title. But in there, Stephen Tobe also talked about that he always starts with the memory allocations first, and they actually do that as well. And I have a talk about this that I've done at several conferences where I talk about this, because I think one of the things that you usually see is that people think that, memory is basically almost infinite these days, right? Because developer machines have gigabytes of memory, and we know we're in a managed language in .NET, for example, C#, and the garbage collector will do its thing, and it will do it efficiently. So why would I care about string split operations or byte array allocations, or, I can just call memory stream to array and it's not going to make a huge impact. But once you start actually tweaking those areas first, then you're getting like lots and lots of benefits, because usually it has a high impact on the allocation, which means less allocations means less GC involved and less sort of stop the world operations. Although I must say, caveat, right, the garbage collector also gets better over the sort of the .NET runtime sort of improvements, of course, in various versions, but still it has an impact if you allocate a lot. But what people also forget is that they usually say, but CPU, when you're burning lots of CPU, can't you get more bang for the buck? Well, the fact is an allocation has also CPU implications, right? Because when you new up something, that takes time. And sometimes when you look at, I'm just newing up a list, people forget that if you don't do that efficiently, for example, with setting a capacity, that allocates space, and every time you do an add, which looks like a harmless operation, the list might need to resize and reshuffle things internally, and stuff like that creates also a huge impact from a sort of a CPU cycle perspective. And if you can start from memory first, getting CPU optimizations, and only then going into sort of the CPU optimizations, which usually is quite involved, especially because then you start talking about algorithmic complexity, O of N notations, and understanding stuff like that. And I'm already getting shivers again, sort of reminding myself about my studies, which I probably have forgotten 80% of the content there. But I would say memory allocations is definitely the biggest problem if we're sort of zooming out on those areas. But of course, there is also I/O involvement, right? And people, I mean, when I'm I'm always trying to give a nuanced answer, because of course, when you're looking at a typical application that uses, I don't know, Entity Framework or HTTP clients and stuff like that, if you're calling an I/O-bound resource like gRPC, WebSocket endpoint, or a database, those calls, they usually take hundreds or thousands of times more time than any CPU or memory allocation that you might have in your code, right? So if you can tweak the I/O-bound path first by tuning database queries and stuff like that, of course, you're getting orders of magnitude of more sort of throughput improvements anyway by doing that. So I think that's important sort of to set in context when we're talking about sort of throughput improvements.
That's a really good tier list of, like, at least a checklist for folks. Optimize IO, then memory, and then if you really want to, then get to CPU optimization. I think that's a really, really good list.
That's really good.
Yeah. So
I am wondering though. Go ahead, Daniel.
Okay, thanks. So I'm a huge fan of sort of this 1% improvement philosophy. It's also a little bit sort of influenced by the book Atomic Habits. I'm not sure if you have read it. It's actually pretty impactful if you look at sort of the compounding effect of little bit of improvements over here, little bit of improvements over there. And if you do that often enough over a longer period of time, the investments are small or small-ish, right? But you're gaining knowledge about the code base, you're gaining knowledge about sort of the assumptions around the code base, which also has tremendous effect about your skill level in the code base. Plus, you're getting sort of these compounding effect of these 1% improvements that make overall the entire application better and better over the long run.
Yeah, that's a really good flaw. I've read that book. It's a pretty good book. So
Yeah,
for
it is a good
folks
book.
who want to check that out, Atomic Habits. I forget who the author is, but
James Clear or something. Yeah,
I actually have the book right here, James Clear.
There you go.
Yeah.
Sweet.
Yeah.
Martin, you were about to say something.
Yeah,
Before you cut
I
off
was going to ask,
Daniel.
like, we've talked about, how do you get started, or where do you get started with performance profiling once you get in? But how do you get in? Where do you start? When do you know that you have issues? What should you do if you suspect issues and all of that? Like, typically, framework, garbage collector are all really good. The runtime is really good. So a lot of people probably not even think about performance, or that they might have issues in there or room for improvements. How do you get there? How do you get to that point?
Yeah, well, I have a good friend in Belgium. I think his name is called Martin. He once said on a JetBrains online conference to me, it's like you should be performance aware. And Martin compared it to like being bear aware when you're hiking in Canada, right? So it's for me, it's kind of the same, right? Because one of the things that I usually say is that, well, like being bear aware when you're hiking in Canada, the likelihood of actually meeting or seeing a bear is probably quite low. But still, if you're trained and you have it the back of your mind, how you should react when you see a bear, that's good knowledge to have. And I think the same applies for being performance aware. So essentially, I encourage people to sort of incorporate it into their thinking about, okay, if we're building software, if we're shipping software, if we're debugging software, maybe try to start with at least doing a performance profile. And I usually encourage people to do at least, of course, an IO profile is good, right? But then do a memory profiling and do a CPU profiling session, because that gives you an overview of what is actually going on in sort of the path that you're looking at, right? Because only then you can actually see what subsystem of your potentially very complicated component interaction graph is doing what, right? And then with that, and combined with your, let's say, domain knowledge of that application, you can basically go and say, okay, well, here I'm pretty strong. I know what's going on. I already see some stuff that immediately sort of clicks in my mind. It's like, oh, it's doing that, this and that in the application. How about we do some 1% improvements over there, right? And then you already have a good baseline to get started with and to basically see where you can focus your attention to. Because otherwise, if you're not narrowing down where you invest your energy into, and that obviously should be limited, and because at the end of the day, unless your essential professional title is performance engineer, which I guess rarely ever anyone has that title, unless you're working for a big company and you're sort of in the 0.1% of the job descriptions, then probably your day-to-day job is actually to deliver business impactful features, right? And not performance optimize the hell out of your code base. So, and that helps to guide your sort of the time that you have and to see where you can actually make impactful changes. Definitely.
Yeah, I've seen teams actually set out and put like performance budgets in place too, to kind of help them make decisions as to when to optimize. So like there's performance budgets in terms of response times, memory usage, CPU usage, and stuff like that. So instead of just shooting for like an obscure goal of better performance, like having set out some performance budgets and how you want your application to operate can also help you make those kind of decisions, right?
Absolutely. I mean, it's good that you bring this up, because when you're looking at sort of, I mean, when you're starting, ideally, right, when you're starting from the architectural standpoint,
Mhm.
a mature team with a, let's say, architect role, I'm deliberately saying a role and not a person,
Mhm.
then I guess you would look into non-functional requirements and also prioritize those non-functional requirements, which include security and other things like performance, like latency, end user facing latency and stuff like that, and SLAs, right? And from that, one of the good things today, if you, for example, are sort of more mature also on the monitoring telemetry side of things, is that you could set up your, for example, open telemetry system to essentially capture or sample 1% or whatever percentage of your requests. And then you basically have real data from how the application is being used in production. And from that, you can then sort of dig over your traces into sort of specific subcomponents. And then when you see something spends a lot of time in your production system, you could then go back and say, okay, let's create a test harness that sort of reproduces that specific entry point into our system, right? And then you basically, from there, you attach a profiler, right? And then you have sort of more sort of granular sort of view into what's actually going on from a CPU, memory, and also IO perspective. And then you can start making tweaks, right? And then you can benchmark those tweaks sort of on the side. And at the end, you put everything into the harness to basically profile it against your improvements. And then once that's done, you ship it. And then you see the immediate impact again on a sort of on an end-to-end telemetry or tracing perspective, right? Which is super cool. If you have that overview.
Yeah, you have to have that baseline to then compare everything else to.
Yeah.
So you kind of took some of my questions. I was going to ask, if you went up a level to the architecture level, were there patterns that you apply over and over again to make sure that, because if you come into, and it sounds like you're sometimes you work with multiple teams, are there things that you bring to new teams, or maybe some teams with a lot of less experienced people that are trying to learn? And what do you bring to those teams to build to make them more mature in the end?
Good question. I think there is a general aspect to that question that I would like to answer a little bit later, but I can also give you a concrete example of, for example, one of the things that I've done in a larger environment. So I was working for sort of a big e-commerce website in Switzerland, one of the biggest ones. And one of the things they had sort of a custom written OR mapper. Right? And one of the things that they have done is they sort of transitioned from IO-bound non-async to IO-bound async. But the problem is, if you have a code base around that has multiple millions of lines of code and 50 teams working on it, how you can basically say, well, we should IO-bound stuff that is synchronous is forbidden, and everyone needs to sort of change their entire code base to switch towards async await, right? But that takes months, maybe sometimes even years of effort. So how do you then prioritize something like that? So what I've done there is I've built into their custom OR mapper sort of a functionality that on every span that is created on OpenTelemetry, it sort of marks the sync IO-bound methods with a specific sort of information or tag that is added to that span. And then one of the cool things is that you can essentially, once you have that in place and rolled out, you get a list of all the controllers that are hit, right, that have synchronous IO-bound code. And then you can order it by the number of requests that you're hitting onto that web API controller, as an example. And then you can say, well, we're addressing sort of like all the ones that, or all the 10 first places, right? And then you're basically go through that code path, change everything to async await, and then you get the biggest bang for the buck, because you have made it visible essentially where the problem is, instead of making a blunt statement that like, let's refactor everything because async await makes everything so much better, right? It's
Exactly. Yep. Go for like you said, with Atomic Habits, go for that 1%, but make that 1% the most impactful 1% that you can do. So awesome.
Well, Daniel, you've been mentioning OTel, or open telemetry, and traces a lot. Like, given that the complexity of modern applications and their infrastructure is getting more complex, do you feel developers today have enough visibility into the systems they're building, or they're blind spots still? I know all of us here have experienced the early days of .NET, and before tools like .memory and .trace came around, it was pretty hard to kind of diagnose these kind of performance issues, right? So is there blind spots today that developers are dealing with, or is kind of the diagnostic tools really good today?
I mean, with all these things, is that these things take time to actually be adopted by the industry, right? So let's say if you just look at sort of what the internet is trying to tell you, where the state of the software engineering world is, I guess everybody would say, well, we have so much insights into what's going on because everybody's using open telemetry. But as a matter of fact, when you look at where the industry is, it takes years to adopt those things. I mean, the example with async await was perfect, right? Sometimes it takes years to be there. And async await has been around since, what was it, .NET 4 or something like that? Or
yeah, I mean, it's at
4.5?
least 10 years now. So.
Yeah, it's insane, right?
Years. Yeah.
I think there are definitely helpful tools around that, like the JetBrains tools that help you to sort of look into a system running. You have counters available, right? You have cross-platform tools today that you can sort of attach on your production system and just look what's going on. You have more sophisticated things like Azure monitoring. You have Grafana, Prometheus, and all these things. But again, I think one of the things that we usually forget is these things, they have a learning curve, right? I mean, it's nice to be able to say, yeah, just set up a good monitoring strategy or whatever you want to call it, and then everything will be golden. But until you are there, that actually every team understands how to use these tools effectively, how you know what a good sampling strategy should be so that you're not like being overcharged for what you're using. We have seen like things, right, in happening there where people suddenly end up paying millions for their monitoring system. So, I mean, I get that Microsoft is trying in the .NET ecosystem is trying to sort of do a shift left where they put Aspire in place and the Aspire dashboard to basically give you helpful guidance so that you can already see it on your development box, right? But I think one of the key things that I think, and that also goes back to Chris's question about what general things do I bring into teams, is I call it sort of the more critical thinking. And I think that's the most crucial part. And that also relates to performance, right? Is that ask yourself, I mean, first of all, I always assume that people before me, they invested time and energy to think about the trade-offs, and those trade-offs might have changed over time. And also the development paradigms and everything has changed. So I tend to not assume that people were sort of dumb before me, right? Because I also only know a slice of what I'm seeing. So I try to sort of think about, okay, how is this going to get called in the production system? Do I have anything in the production system that gives me real data that I can sort of use to guide my investments in time? Can I use tools like .trace, .memory, or my open telemetry spans to sort of guide my attention and stuff like that? Can I use something like benchmark.net to sort of prove that the changes that I'm making on sort of a more micro level are actually making things faster and not the other way around, right? So but it's a combination of basically architectural trade-offs, design choices, critical thinking, making a step back, and sometimes the best solution in terms of performance is when you're not writing any code, because when a request never hits your endpoint, then you have infinite scalability, right? So these are other things that sometimes people forget in sort of once they start to understand the problem space, in the solution space, sometimes it's actually absolutely viable to not build a feature, or to maybe offload the feature to a third party. Then it becomes the third party's problem, right? Or introduce a CDN in between, so that you never actually get the requests, or you're only getting 1% of the requests. And then it might not even matter if the request takes 2 seconds, right? Or something like that. So,
Yep.
Yeah.
Yeah, it's interesting. You're talking about critical thinking. Have you ever seen a team adopt quote unquote performance improvements based on like pseudoscience? Because as developers, sometimes we're looking for like the silver bullet, and you know, in a generation of TikTok and 30-second solutions, you can see a lot of teams adopt something that they think will make their applications operate better, but then ultimately is counterproductive.
Yeah, it's the golden hammer.
Yeah.
You mean like adding two levels of caching in between the database and your actual application logic, things like that?
Just cache everything. But are there performance traps that teams fall into because, you know, they saw 4 guys on a YouTube channel talking about it and thought it was a good idea just to jam it in? No, I'm just joking. I'm just
No, it happens. I bet it happens more likely. Well, look, people are always trying to find the little gems, and sometimes those gems. We used to say, you know, everyone's trying to find the shiny pennies, and sometimes in the end they're using rusty washers. So,
I mean, to be honest, I mean, reflecting about my, I don't know, 15 years of doing .NET development, I have also made these mistakes. I mean, appeal to authority is a big thing, right? Sometimes we see someone talking that we admire, and we are like, oh, Martin does that, so I should do it as well. It must be great.
Don't do what
I always do that.
I do the opposite. If I see Martin doing something, I'm like, all right, I gotta go the other direction.
I go Martin's way, so more times than not.
And to be honest, it's also, I mean, one of the big things in the industry that I've also fell into the trap was everything that Microsoft released, I always jumped on it until I learned that you should probably wait for the second or third version of what they released before you adopt anything. Did I say that out loud?
We've all made that mistake.
We've all done that. Yeah. We've all done it, or just done what they did in demos. Yeah. So, or just follow demos.
Also, Daniel, it's fine to say such things because there's only 5 people watching this one, which, by the way, if this is one of you, hit that like button and subscribe.
Yes, subscribe and like down below. So, I have a question. So, you know, we talk about all this complexity and using profilers and using third-party tools. Are there like 2 or 3 things in C# and .NET that you wish all developers would understand more to make their software better? Now, we've already gone over async and await, the asynchronous programming paradigm, but is there anything else that you just, when you see code and you're like, oh, I wish people would learn this in C# and be better?
Okay. I mean, definitely, I would say if we're just talking about sort of runtime stuff, I mean, span and memory of T is one of the biggest improvements since async await, right? Because it makes so many things possible these days that you can just operate on arbitrary chunks of memory or stack allocated space, and then just basically you can avoid copying around stuff, which makes things so much faster overall. That is definitely something. Conceptualizing what span and memory is and then knowing where to apply it, I think is great. One thing that goes into that one is sort of being aware of what is an allocation, what can I do to move allocations around. This is more sort of a general engineering practice. And then when we go back into .NET, I guess one good thing to learn is sort of memory pooling, array pooling. That's a good thing. I think everybody should know array pool.shared because that's, especially when you want to build up this sort of performance awareness, that's a great tool to know. Combined with that, if you're in the sort of more advanced territories, potentially stack allocations is a nice feature to understand, the stack alloc keywords. But I think that's more or less it from my end.
Okay.
Well, I guess I have the opposite.
Let's let Martin ask a question.
Wait, I have a good one here.
We all have so many questions.
I mean,
you go ahead, Khalid. You do it. Go
all
for
right.
it.
But like I'm a caveman. I don't have, if you doubled my IQ, it'd still be single digits. Like the question I have is like, there's so much complexity around memory management and garbage collection. It's like, I know a lot of .NET developers, it's just a day job. I want to come in, I want to do my work. Like, why can't .NET just do this for me? Right? I think there's a lot of people out there thinking like, why doesn't it just do the right stuff all the time?
I mean that, and honestly, I think ultimately coming to that conclusion after you have gone through actually analyzing it and understanding it, I think it's fine, right? But again, for me, it's about basically explicit trade-offs, because when you look at performance optimizing, especially when we go into sort of CPU optimizations or even memory allocation, when you start pulling in, instead of doing new byte array, you start having stack alloc keywords and skip locals in it, and then you have array pool in there. The complexity of this code just explodes, right? And that comes with a cost, because you need to understand it, you need to maintain it over time. And thinking about that is also important, because I'm always against sort of blunt statements like, oh, don't use link on the hot path, right? Because it's like, I mean, come on, link gets optimized over every .NET version. It gets faster and faster and faster. And there are a plethora of use cases where link is the best tool at hand. Don't worry about it, just use it, right? And you will get for free performance optimizations. I think at least my context in this conversation was, we're talking about a critical hot path in my applications where I'm getting hit by thousands and thousands of operations potentially a second. That's where things start to matter. When it's something that you're doing sort of offloaded somewhere in a background thread, or I don't know, maybe you have a queue in between. If it takes a second or half a second or 2 seconds, I mean, why bother? It's like, or if it's a scheduled job that runs once a day, I mean, please just write the simplest code possible. And actually, I always start like that. I always write the simplest code possible with a few tests that sort of implements the sort of the business requirements, and then look at it. Are there low-hanging fruits that you can tweak a little bit, optimize it slightly, but then ship it? Because you can make thousands of assumptions. If it's not out there running in production, you don't know. It's you're blind, right? Ship it, and then you learn and you adopt. But since you have tests in place, it's easy to then sort of start making a few tweaks, send it up to your CI/CD system. As long as it passes the test, you should be fine. If their test case is missing, add more. And then you can iteratively improve it. Again, 1% improvement. And you can improve it when you see the need to improve it, right? And I think what's near and dear to my heart to also hammer home here is, we talked a lot about this nebulous complexity of performance improvements. And I don't want to get the impression that it's only something that is applicable for very, very smart people, because I think everybody can do this. And everybody can start somewhere, because even just looking at the code that you wrote, and think about, okay, I'm doing here some string manipulations, or I have a tight loop. Can I move something out of the loop, right? And ask yourself that question and then conclude, no, it's not possible, and then move on. Or, oh, actually it is. Let's move it up. You've already made the code better, right? So,
Yeah.
and then gradually, if you apply this type of thinking, you can add more stuff to your tool chain, right? You can say, how about we throw it into a profile? How about we do a quick memory profile? And even if you do it a few days before shipping, just run your code, attach profile, have a look through and see, oh, there's something awkward happening here.
Yep.
Can we make this better? Do one improvement, ship it, and then move on, right?
Yeah.
So gradually,
Yep.
you're building up this culture of being more performance aware.
Yeah. I'm sorry, Martin. I've got to have a question. We're not letting Martin have any time.
So the good question is my question that I did not ask or not get to ask was answered in this.
Oh, you did?
No, the question was answered.
Okay. So we didn't need you at all on this. So
I can just retire and sign off. It's
good.
fine.
Good. Hey, so Daniel, you know what? And I'm not gonna. I guess I'm gonna plug myself. I do a talk, and this is interesting. I want your perspective on this. I do a talk around link performance, mostly around entity framework, where I go, just because your link statement works doesn't mean it's optimized, and you may have to jump over into SQL Server and take a look at the performance of that. But you talked about you're a big event driven, and you work with a lot of messaging platforms and technologies. Do you find that some developers don't jump into those and get the optimization out of all the systems that their actual code interfaces with?
Not sure I entirely understand.
Well, so let's jump back to like SQL Server. I mean, we've all had queries that ran in our application. Say, and you identify it as like a 3-second query. It takes 3 seconds to get back the return payload. So most developers would go, okay, checkbox, it runs, I get data back. It's a little slow, but it runs, so I'm just going to release it. For me, I say, okay, you may not be comfortable jumping into SQL Server, but you should learn SQL Server optimization because it's part of your bigger system. So that's what I'm saying. So say you have your core application, but then we interface to database engines, and we say, like you brought up Azure Service Bus and all these Azure resources that we use over and over again. Have you found places in certain common third-party tools or other platforms that people should really dig into and learn more about?
Okay. I think there are multiple aspects to this question.
Probably.
One aspect for me is like, I do agree with you that if you're using a database, then you should understand sort of, is it a relational database? Is it a document database? Has it partitioning built in? And sort of that general knowledge, and then knowing what that means for your code and for your queries and stuff like that is important, because otherwise you're going to end up with using something like Cosmos DB, and then you're going to cry because the bill is too high, because you use it for something it was never built for, right? And and then I think the same applies here with when you're using SQL Server. It's good to build up as a team some knowledge about it's good to build up knowledge around how does this query actually translate into a query plan, and then sort of from that basically understand, well, there is IO involved, and there is materializing involved on the client side, on the server side. There's the TCP/IP stack in between. sort of right. But you can gradually expose yourself and build up that knowledge, and that for me comes into sort of knowing the context of what you're operating in, knowing the ecosystem standards and trade-offs, and then building the right solution. And that's where the simplest thing comes into place. The simplest thing in that context means for the specific context you're looking at, and not just the simplest thing that you come up in your mind, ignoring the entire ecosystem standards, right? I didn't want to say that.
That's awesome. No, I've always been it's a pet peeve of mine when I deal with teams and they just go, well, my code works fine. It's like, well, we have to look at the system as a whole. And now that we're pulling in lots of different systems, like I get a lot of pushback around using like a service bus or a messaging system because people think it's slow. They go, well, why can't I just do an API call, do a direct call to something, and I have to sit down and talk about trade-offs and dependencies and just everything. And sometimes, yes, an API call from point A to point B can be the fastest thing, but then you're giving up you're giving up coupling, and you're coupling two systems together, and there's a lot of other stuff.
But I think I've seen both ends on the spectrum, right? I've seen basically people only knowing one tool like HTTP and only using that, and never actually going back and saying, for this use case, is this really the best way to communicate, or should we evaluate different options? What different options are there? And then going from there towards saying, oh, we should never be using HTTP. Everything should go through a durable message queue, right? And then I've seen people building query engines on top of messaging, which is ridiculous. Like, no. Right?
Exactly.
But knowing those trade-offs, and honestly, sometimes people, when I talk to them about these type of topics, they think, oh, you have to know an entire book of wisdom in order to come up with these trade-offs. But as a matter of fact, you can have a decision log or an architectural decision record where you basically list a few bullet points of when is a queue good or not, and why you have chosen it here in this specific case over another, right? And then from that, you can extract a few pragmatic guidelines where you can say, look, every time you're designing an API, ask yourself these 5 questions. And then if it's more on this side, use a queue. If it's more on that side, it's use an HTTP endpoint or whatever.
You're right. Yep.
Right? It's like, it's not rocket science. It's, to be honest, of course, learning the more advanced architectural patterns requires time and maybe seniority, but you can own that together in a team, right? It's and you can build that context up. So, yeah.
Okay. Well, we will give the last question to Martin.
Here we go. No, you talked about the 1% and every single time making small iterations and trying to make the code better and so on. But that also brings in a paradox in that if you optimize 1% of 1%, 1%, you will never hit 100%. So when on that spectrum do you stop optimizing things? When do you know it's enough?
When the router switches off the internet at midnight. No, no. This is a very interesting topic because it's very hard to give generic guidance on it, because I've said this before, performance optimizations can be very addictive because you basically iterate over sort of making changes, measuring, and then you see how things are getting better and better, and this sort of wakes up sort of this motivation to do more and more and more, right? So like Khalid said, having a budget, maybe as a team, that you can also sometimes say, we don't always have to use it. It's also okay to not use it when we don't need it. is nice. Or maybe have checkpoints, right? Where you say, okay, before we release a feature at stage X and stage Y, we at least attach a profile and we look into it, right? And then you do that. And we give ourselves a budget of, I don't know, 2 hours, 4 hours, 2 people, or whatever that is, right? Start small. But I think it's the same sort of question people ask. It's like, well, should I do refactorings and redesigns? Right? It's like, oh, and remove technical debt. It's hard to justify that to the business. I mean, why have we ended up in this area? Why I mean, if I'm building a house, I'm not arguing with the architect about, I don't know, safety and electricity and whatever. It's like, I assume that they do a professional job because I hired a professional to make sure the freaking house holds up, right? So
the problem is you're dealing with that. We're dealing in the real world with physics and atoms. And to be honest, in software, there are no, I mean, the great thing about software is there's no limitations in some ways. And then the bad thing is there's no limitations in those ways. So
I agree. Yeah.
I mean, we have boundless ideas, but Daniel, we have so many questions. We need to get you back on for a future episode, because I never asked about AOT, about dependency injection, about tons of stuff that I would love to pick your brains about. But we have to wrap up, and I just want to thank you. I'll let Martin and Khalid have the last word from each.
I would like to thank you as well. This was a super enlightening episode, and I would love to have you back on for part 2 of this one.
Cool.
Yes.
I would definitely be up for it. Absolutely.
Cool. Yeah, I think next time we'll settle this Belgian Swiss chocolate thing. Martin, Daniel, you're gonna ship me chocolate from your respective countries,
Me too.
and I will judge. I'll be judge, jury, and chocolate eater, I guess.
This is going to be one of those eating videos on YouTube, isn't it?
Yes.
A mukbang technical video.
But don't put any ghost peppers or Carolina Reaper peppers
no funny
in them.
stuff.
So no funny stuff in there. So well, Daniel, thank you. We really appreciate you being on the show. We'll put Daniel's contact and how you can kind of learn more about Daniel in the show notes. Again, if you're watching this on YouTube, like and subscribe down below. It really helps us out with the algorithms. Somehow, I don't know how the algorithms work, but they say the algorithms, the more likes you get, the bigger audience you get. But
I believe it also looks at crazy faces on the stream. So now is the time for us all 4 to make a crazy face.
Yeah,
we are.
Yeah, there we're gonna shoot up. We're gonna skyrocket. So thank you.
I want to quickly pitch that I'll be at NDC Oslo with sort of talking about the performance loop on stage, and I will also be at NDC Porto if people want to catch up with me in person.
Nice.
To talk about the performance loop. And
will you be at Copenhagen?
No, unfortunately not.
Okay.
Yeah. That would have been my dream because it's the best craft beer place in Europe. But
I remember that. Oh, good. Okay, well, thank you. This one's gone on a little longer, but you know what? It was worth going longer. So, Daniel, thank you very much. And until 2 weeks from now, when we're back, we will say goodbye and happy performance hunting.
Bye, everybody.
Bye-bye.
Bye, everyone.
Yeah.